Welcome back everyone. This is the session 8 from the playlist of JEE Advanced Part 2. The topic is motion of a charge in an electric field, and I've taken here one question which was asked in the IIT JEE Advanced paper in the year 2020. This question is based on this topic, that is motion of a charge in an electric field, and the question here is a positive charge Q of mass m is projected at an angle theta in a region of electric field given by E is equal to minus 400 root 3 y Newton per coulomb. Now here the minus sign is indicating that the direction of the electric field is along the negative y axis. Now this charge hits the particle T, which is 5 meters away from the point of entry, as shown in this figure. So in this question we have to find the time of flight of the charge and its angle of projection if the initial speed of the charge is 2 root 10 into 10 to the power 6 meter per second, and here we have been given one more this quantity, that is Q upon m is equal to 10 to the power 10 coulomb per kg. So when this charge enters into this electric field region at this point O, then it will be experiencing an electrostatic force. Now since it is a positive charge, therefore the direction of the electrostatic force will be along the direction of the electric field. Now here in this case the direction of the electric field is along the negative y axis, as indicated by these two arrows. So therefore the direction of the electrostatic force will also be along the negative y axis, and it will be given by the formula, that is F is equal to QE. This F is the electrostatic force on this positive charge due to this electric field, and this is equal to m into A, where m is the mass of the charge and A is the acceleration of this positive charge due to this electrostatic force. So from this equation we can find the value of acceleration, which is equal to Q upon m into E. Now Q by m is given in this question as 10 to the power 10 coulomb per kg, and the value of E is equal to 400 root 3. So this is the value of the acceleration of this positive charge due to this electrostatic force, and I will be writing this value of acceleration of this positive charge here on this board on the left hand side, which is equal to 10 to the power 10 multiplied by 400 into root 3, and this will be in meters per second square. Now when this charge enters this electric field region at this point O, then it will be experiencing an electrostatic force along this negative y axis, and because of that it will follow a projectile motion as shown in this figure here, and it will hit this particle T at this at the point A, which is at a distance of 5 meters from the point of entry. Now here as we know that the formula for the range in the case of a projectile motion is equal to u square sine 2 theta divided by g, where g is the acceleration due to gravity, and this formula is applicable when the object is moving moving in a projectile under the influence of the gravity. But here in this question we are neglecting the influence of the gravity, and we are only considering the acceleration of this positive charge due to this electrostatic force. So because of that, the range in this case will be equal to u square sine 2 theta divided by A. Now the value of A, we have already calculated the value of A, this acceleration of this positive charge. So from here I can find the value of theta. So sine theta is equal to range multiplied by the acceleration of the positive charge divided by u square. Now here range is 5 meters, acceleration is given as 10 to the power 10, range is 5 meters, acceleration is 10 to the power 10, 10 to the power 10 multiplied by 400 into root 3 divided by u squared. Now u is the initial speed of the charge, so this is equal to 2 root 10 into 10 to the power 6 in this question. So this will be equal to 2 root 10 into root 10 to the power 6 whole square, and this is sine 2 theta. So in this question I will be only solving, or I will be finding the value of the angle of projection only, because once you find the angle of projection then you can easily find the time of flight. Okay? So first of all let us find the angle of projection. So angle of projection can be found by using this this formula, that is sine 2 theta is equal to 5 into 10 to the power 10 into 400 into root 3 divided by, this will become 4 into 10 into 10 to the power 12. So from here we will be I will be getting this equal to 5 into 1 is equal to 5, and this equal to 2, and this will get cancelled out, and this will become 100, and sine 2 theta will now be equal to this will be 10 to the power 10 into 100 will be equal to 10 to the power 12. So 10 to the power 12 into root 3 divided by 2 into 10 to the power 12. So this 10 to the power 12 will get cancelled out, and finally I am getting root 3 by 2. So sine 2 theta is equal to root 3 by 2. So I will be writing this value here, that is sine 2 theta is equal to root 3 by 2. So if sine 2 theta is equal to root 3 by 2, so this root 3 by 2 can be written as sine 60, or this can also be written as sine 60 can be written as sine 180 minus 120. Okay? So if sine 2 theta is equal to sine 60, then 2 theta is equal to 60 degrees, and theta will be equal to 30 degree. And in the second case, sine 2 theta is equal to sine 60 can also be written as sine 180 minus 120, and so this value is equal to what? This is equal to sine 2 theta is equal to sine 60. This is equal to sine 180 minus 120. So this is equal to sine 120, because sine 180 minus theta is equal to sine theta. So using that formula, we can write this sine 180 minus 120 is equal to sine 120. So from here, 2 theta will be equal to 120, or theta is equal to 60 degree. So what I am getting here is that theta is equal to 30 degrees or 60 degrees. So the angle of projection of this positive charge is either 30 degrees or 60 degrees. So we have been able to solve the first part of this question. Now the second part of the question is very easy. So I will not be wasting a lot of time on the second part. I will just giving you the formula for it. That is, the time of flight is equal to 2u sine theta divided by a. This is the formula which you must have studied while while studying about the projectile motion. So in the projectile motion, the time of flight is equal to 2u sin theta upon g. But in this case, in this question, this formula will be equal to 2u sin theta upon g, because we have neglected the effect of gravity and we have only considered the acceleration of the positive charge due to the electrostatic force. So here we know the value of u. We have already find the value of theta, which is equal to either 30 degree or 60 degree, because the value of theta which we have just found was either 30 degree or 60 degree. So if I put the value of sine this theta here as 30 degree, then this value will be equal to 1 by 2. We have been given the value of the initial speed as 2 root 10 into 10 to the power 6 meter per second, and we have also found the value of acceleration of this positive charge. So putting this value of theta as 30 degree, we can find the time of flight when the angle of projection is 30 degree, and we can also find the time of flight we can also find the time of flight when the angle of projection is 60 degree. What we will do is we will simply put the value of theta as 60 degree, and we can find the time of flight when the angle of projection is 60 degree. So we will be getting two time of flights, one when the angle of projection is 30 degree and the other one when the angle of projection is 60 degree. So the most important thing in this question was to find this angle of projection. Once you find this angle of projection, simply you have to use this formula, that is you have to use this formula for calculating the time of flight, that is t is equal to 2u sin theta divided by a. So thank you very much for joining this session. I hope you have understood the solution of this question. In the next question, I will be coming up with a different type of a question, but the chapter will remain the same, that is electric charges in field. So till then, have a nice day. Bye.